Power dissipated by resistors. Three identical resistors are connected in series. When a certain potential difference is applied across the combination, the total power dissipated is 45 watts. What power would be dissipated if the three resistors were connected in parallel across the same potential difference? So first we have three identical resistors connected in series across a voltage source V. The equivalent resistors for the series combination of three resistors is going to be 3R. So the resistances add up. The power dissipated by these resistors in this combination is the power supplied by the battery, which is V squared divided by 3R, and that is equal to 45 watts. Now we're connecting the three resistors in parallel. So when we do that, they are connected to the same voltage supply V, so the same voltage appears across these resistors. The equivalent resistance of three resistors connected in parallel will be 1 over R equivalent is equal to 3 over R. So 1 over R plus 1 over R plus 1 over R. Therefore, the equivalent resistance in this case is going to be R divided by 3. So what will be the power consumed by these resistors? Well, the power P is equal to the voltage across the equivalent resistance, which is V squared. So V squared divided by R over 3, the equivalent resistance, which is 3V squared over R. So V squared over 3R was P0, 3V squared over R then is 9 times the power dissipated in the series combination. So I find that the power dissipated by these resistors should be 9 times 45. P is equal to 405 watts. Okay, so in this problem we have three resistors connected in series across a voltage source V, so they have the same current appearing on them. The voltage is divided, so it's V over 3 plus V over 3 plus V over 3, that will add up to V here. The equivalent resistance of the three resistors in series is 3R for the identical resistors. The power dissipated is the voltage across the equivalent resistor 3R, which is V, squared divided by the equivalent resistance 3R, that's 45 watts. Now they're connected in parallel, the same voltage appears across them, their currents will add up, so the current will be divided into 3, I over 3, I over 3, I over 3. The total current I will flow back to the voltage source. The equivalent resistance is 1 over R equivalent is 1 over R plus 1 over R plus 1 over R, 3 over R. So equivalent resistance is R over 3. If I take the reciprocal, then the voltage is the same, V, across the equivalent resistance. So it is V squared over R over 3, 3V squared over R, 9 times the power dissipated in the series combination, 9 times 45, 405 watts.